Today, we are talking about something that is, honestly, one of the most misunderstood parts of science, the null result. Get ready, because we're about to completely change how you think about failed experiments. Okay, so let's just start with this question. What if our constant search for those big eureka moments is actually making us miss a huge part of scientific discovery? What if the real breakthroughs are actually hiding in the experiments that look like they failed?
Well, that brings us to what's known as the file drawer problem, and it's kind of a silent epidemic in science. Just try to picture it. Countless hours of research, all this carefully collected data, really valuable insights, all just locked away in a metaphorical file drawer. Why? Simply because they didn't get a positive result. And this isn't just a missed opportunity. It is a massive waste of knowledge.
So, let's dive into our first section here. Science's silent problem. We're going to peel back the layers on this and really get to the bottom of what these unpublished results are costing all of us. First things first, let's be super clear about what we're talking about. A null result, or a negative finding, it's not a mistake, it's not a botched experiment, it's a real, legitimate scientific outcome. All it's telling us is that our initial hypothesis was probably wrong, and that, as you're about to see, is incredibly useful information. So you might be thinking, what's the big deal? A few studies get put away, who cares? Well, the consequences are actually way more damaging than you'd probably guess, which brings us to our next section. You see, the ripple effects from this are just staggering. When we only publish the exciting results, we end up creating this totally warped view of reality. It's called publication bias. And that skewed picture, it leads other researchers down dead-end paths, wasting so much precious time, money, and resources on ideas that, you know what, have already been tested and didn't pan out. It's like a domino effect that slowly chips away at the foundation of scientific progress. But what if we started to embrace these so-called failures? The upside is huge. We get much more accurate research syntheses, we could refine our big theories based on what doesn't work, and we'd build this amazing culture of transparency that could truly speed up discovery. It's a pretty simple shift, really, but with some profound implications. Okay, so how do we fix this? How do we turn this whole problem around? Well, it really all starts with a change in how we think, right from the beginning of a study. That brings us right to section 3, designing for clarity. Having a strong foundation for your study is absolutely everything. You need a clear question from the get-go, you have to be totally transparent about your methods, and, this is a big one, you have to justify your sample size. That last point about statistical power is so important because it shows that your study was actually sensitive enough to find a real effect if one existed. That's what makes a null result so much more meaningful. So, you've got this solid study design in place. Now it's time to share what you found with the world. And that brings us to our next big topic, reporting with integrity. Let's talk about how to communicate results with total honesty and clarity. I mean, look at this. The difference between vague and informative reporting is like night and day. Just saying the result was not significant is basically a dead end. It tells us next to nothing. But if you provide the detailed data, like how big the effect might have been, or the exact probability values, you transform a failure into a super valuable piece of the scientific puzzle. Right. So transparency is the name of the game. It means you report all the analyses you plan to do, not just cherry-picking the ones that looked good. And if you really want to level up, there are some pretty cool statistical methods out there. For instance, something called equivalence testing can actually provide positive evidence for the absence of an effect. Think about that for a second. It's not just failing to find something, it's actively finding nothing. That's a powerful conclusion. And this all leads us to a really crucial turning point. It's not just about what we report, it's about how we talk about it. So in section 5, let's explore how we can shift our whole perspective from nothing to knowing. This is a subtle one, but it's so important. The difference between no evidence of an effect and evidence of no effect. The first one is basically an inconclusive shrug, right? The study might have just been too small or flawed, but the second one, that is a powerful scientific finding. It's the difference between being uncertain and actually knowing something. Honestly, saying nothing happened is just kind of lazy and misleading. Precision is what we need. A well-reported null result is actually a very definitive statement. It says, look, we searched for this specific thing in this specific way, and we can confidently say that effects of this particular size are not there. That is incredibly valuable information for anyone who comes after you. The way you frame all this really matters. You should never apologize for a null finding. Own it. A well-designed study that finds no effect did not fail.
You just need to connect your findings to the bigger picture and focus on the knowledge you've just added to the scientific community. And finally, let's talk about the long game, the long-term impact of your research. In our last section, we'll cover how you can make sure your null results keep contributing to science for years and years to come. The absolute best way to maximize your research's impact is to just embrace open science. When you share your data, your code, and your materials, you're not just being transparent, you're literally empowering the entire scientific community to learn from what you did, to grow, and to build on your work. So here you go, a simple little checklist to keep in mind. If you just run through these questions, you can make sure that your research, no matter what the outcome was, is a valuable, strong, and clear contribution to science. So I'll just leave you with this thought. What could we achieve if we started valuing every single piece of the puzzle, not just the ones that neatly hit what we expected to find? Just imagine the breakthroughs waiting for us if we embraced failure as just another stepping stone to knowledge. The future of science really depends on it.